So let's look at naming ionic compounds that contain polyatomic ions. We still know how to recognize these. We know that almost every single ionic compound is going to have a metal, cation, and it's going to have a nonmetal anion. We know we consistently name the metal cation by the name of the element. If it's type 1, we just leave it there. If it has a variable charge, we're going to put the charge in Roman numerals in parentheses, followed by the name of the nonmetal. And remember, a nonmetal is named as its anion, and we have to know and memorize all the names of the anions. So what we're going to do here is add some more anions to this list. So let's make sure we remember our type 1s. Remember, hydrogen appears in 2 spots. It can either be in group 1, which is where we'd name it hydrogen because it's positive charge and it's a cation. If it's over here in group 7 and we know where it's going to be and what we're going to do with it. For example, if we had HCl versus LiH. With LiH, we know that this is lithium. It is a metal. Hydrogen is going to have to be a nonmetal. We'd name it as a nonmetal, so this would be lithium hydride. Here, these are both nonmetals, and we're going to name these differently, but hydrogen here is in the front, and we're going to call it hydrogen. So our type 1 metals, again, is groups 1, 2, and 3. Silver, zinc, and cadmium. Our type 2 is everything in the middle with a variable charge. So polyatomic anions. And I know you take a look at this list, and it's a bit unnerving in terms of the number, but the reality here is most of these follow a pattern. So we're going to start out with a few that don't, which are these guys right here. Cyanide, hydroxide, permanganate, and acetate. Chromate and dichromate you'll see around, but do not memorize these, so do not. All right, the rest of these guys you're going to need to memorize. So let's take a look at those first 4. So we're just going to have to remember here that hydroxide is OH minus. We're going to have to remember that Cn minus is cyanide, that permanganate, MnO4, and be very careful with the numbers here. The 4 means 4 oxygens. The charge is -1. Don't confuse those and make it a -4. And this is permanganate. And the other one you need to know is acetate, C2H3O2 with a -1 charge. All right, those are the irregular ones, and you just have to commit those to memory. But we have many polyatomics that we're going to describe as regular, meaning they form a nice regular pattern. And the best way I can have you memorize these is to do this. And this is Nick the Camel, 8 clams for supper in Phoenix. Now, if you look at Nick the Camel, 8 clams for supper in Phoenix, and yes, I know it's stupid, Nick the Camel, 8 clams for supper in Phoenix gives us the anions that end in 8. Now, note here, our nice regular polyatomics tend to have 2 endings. They tend to have an 8 ending, and they tend to have an 8 ending. So, for example, NO3 minus here is nitrate. NO2 minus is nitrite. The difference between the 8s and the ites are always going to be 1 oxygen. So to go from the 8 to the ite, you are going to subtract 1 oxygen. And I consider the ites to be like light and oxygen. So just pull off 1 oxygen, everything else is the same. So how does Nick the Camel help? Well, Nick the Camel gives us the pattern for what we need for our 8. So starting with Nick. The N at the front is the element that's not oxygen. The total number of consonants, N, C, and K, is the number of oxygens, so that's 3. The number of vowels is going to be the charge. So the number of consonants is equal to the number of oxygens, and the number of vowels is equal to the charge. So if we take a look at Nick, we have N for the first element, non-oxygen element. There's 3 consonants, so we have 3 oxygens. We've got 1 vowel, so our charge is going to be -1. So that is going to be nitrate. We name it from the non-oxygen element. So Nick gives us nitrate. We pull off 1 oxygen, we're going to have nitrite. Let's do the rest. So if we have camel, so Nick the camel, 8 clams. We'll do clams at the very end here, for supper in Phoenix. So what do we have here? We have a C at the beginning. We have 3 consonants, so we have CO3. We have 2 vowels, so we have 2 minus. This is the 8 ion, so this is carbonate. If we do supper, we have S. We look at our total number of consonants, that is going to be 4. We look at our number of vowels, that's 2. So SO4, 2 minus is sulfate. This is going to tell us immediately that SO3, 2 minus, again removing 1 oxygen, is the light version, and that's sulfite. If we go to Phoenix, we have a phosphorus, we have 4 oxygens, we have 3 vowels, and this is phosphate. All right, so that gets us through our 8s and our ites. So what are we going to do with this? Well, we can do one more thing with this mess, and we can take and add hydrogens to it. So if we have our carbonate, and we add 1 H plus to it. Now, because this is the plus, it's going to be named as the element, so that's hydrogen. Because we've stuck it on a carbonate, carbonate is still carbonate, so this is hydrogen carbonate. And if we take and add our charges, we're now going to have HCO3 with a -1. So HCO3 -1 is going to be hydrogen carbonate. We don't have to memorize it separately because it still comes from Nick the Camel ate clams for supper in Phoenix. This is still carbonate. All we've done is tack an H plus on it. And we can equally do this with sulfite. We can do this with sulfate. We can do this with phosphate. And we can do this twice with phosphate. And when we do this, remember to add our charges, and we're going to get HSO3 minus, and this is going to become hydrogen sulfite. If we do it with the sulfate, it's going to be hydrogen sulfate. If we do it with the phosphate, and again, remember we add up our charges, and we're going to have hydrogen phosphate. If we happen to put 2 hydrogens on it, we're going to take and put a 2 here, PO4 minus, and we have to change the name on this one. This is dihydrogen phosphate. All right, what does this give us? Well, this gives us a great chunk of our nice polyatomic anions. So what are we going to do from here? Well, now we leave us with the clams. Now, our clams is a little mediocre, but we're going to run with it anyways. Cl, we're going to use for chlorine. But because chlorine is its own element, when we do this, we count this as 1 consonant. I know that's kind of crap, but nonetheless, that's how it is. And we're going to do ClO3, or the other 2, counting the M and the S, with a -1 charge. How does that help? Well, if he ate clams, then this has to be chlorate. So if that's chlorate, we can do chlorite, because we know chlorite is 1 less oxygen. This is chlorate. So we can do 2 more from here. We can take and we can have even 1 fewer oxygen. And if we do, we only have 1 left. This is very low in terms of our oxygen, even less than chlorite. And we treat this like we would something in biology where we'd have a really low concentration, and we would call that a hypo something, like a hypotonic solution. And this becomes hypochlorite. And if we take and we put 1 more oxygen on, which is the last possible option, this would be like hyper in terms of the number of oxygens. But for some reasons that I could not possibly explain to you, we take the HY off, and this is perchlorate. So our pattern is hypo with ite, ate, and per, and ate. These two make reasonable sense, and these come seriously straight out of biology with hypo and per. And remember, per is going to be one more than chlorate. Hypo is going to be one less than chlorite. Note you can also do this series with bromine and iodine. So that gets us through the polyatomics. Now, what do we do with these? Well, we name these the same way we would name an ionic compound, straight binary, except now we have polyatomic. So if we have K with our CO3, and one thing that you may want to do with this is you may want to stop and think about what is your cation, what is your anion. Remember, we named this by the name of the cation. Well, that's potassium. And whatever is left on this mess has to be the anion. Well, we look at this and you go, okay, Nick the camel, 8 clams, and this is carbon, so we know this is camel, so we know this is carbonate, and that's it. That one's done. Now, we've got 2 other polyatomics. Our last 2 polyatomics are cations. And we have to memorize these. There's no particular pattern on these. Our polyatomic cations are NH4 with a positive 1 and Hg2, 2 plus. Mercury makes itself a diatomic, di meaning 2. Each one of them are plus 1. Because each one of them is plus 1, it is mercury 1. You asked, do I have to keep the 2 there? Yes, that's how it exists. So if I go down to this next one, and I have NH4Cl, well, NH4 is this guy, and this is ammonium. So NH4Cl is ammonium. We name chloride as the name of the anion. That's it. And then we go down here to Cu2SO4. Well, Cu is our metal, so that's copper. We know this is a type 2 metal, so we need the charge in parentheses. SO4 is a polyatomic anion. It contains oxygen. So we're going to start with Nick the Camel ate supper. So if we look at supper, we know we have an S. We have a total of 4 consonants. So this is going to be sulfate. But we also know, because we have supper, we have 4 consonants and 2 vowels. So sulfate is 2 minus. So if sulfate is 2 minus and we have 2 coppers with it, each copper must have a charge of plus 1. So this is copper 1 sulfate. So let's do a few more. How about nickel 2 phosphate? Well, nickel 2 means it's Ni2 plus. Phosphate, we go to Phoenix. And if we look at Phoenix, this is PO4, 4 consonants, so therefore 4 oxygens, 3 vowels, there was 3 minus charge. We're going to cross multiply, and we're going to have Ni3, PO4, and we need 2 phosphates. So anytime we have a polyatomic, and we have more than one of a polyatomic, we have to put that in parentheses. Otherwise, we'd have 42 oxygens, and that's a little ridiculous. So if we go to calcium hydroxide, calcium is in group 2. Hydroxide we've memorized as an OH minus. Because this is minus 1 and that's 2, we need 2 hydroxide, and that's CaOH2. Right here, NH4. NH4 is one of our polyatomic cations. We know it's a plus 1 charge, and that is ammonium. CO3 2 minus, we know this from Nick the Camel, is carbonate. And that's it. ZnSO3, well, Zn is zinc. SO3, well, we're going to go again to Nick the Camel ate supper. So if we look at supper, this is SO4 2 minus. Remember, 8 clams, so this is sulfate. Well, this is 3 oxygens, so this has to be sulfite. Zinc is a type 1 metal, so there's no charge needed. So let's do one more, and let's do PbClO2. All right, so ClO2. So first of all, we know this is lead. We know lead is a type 2 metal, so we need the charge in parentheses. ClO2, we're going to go to our clams, and we're going to remember that this is going to be chlorite. And when we look at our charges, our chlorite, remember clams has one consonant, so it's a -1, and we have two of them. Therefore, the charge on the lead has to be 2. Lead 2 chloride.